Good afternoon. I'm Hailong Liu, a researcher from Naoya University in Japan. Today, I will talk about the explicit behavior affected by driver's trust in a driving automation system. Before my presentation, actually I had applied for a business visa of the United States 2 months ago, but it's still checking my background now. I think maybe the Mr. President Trump knew me more than my mom. Okay, forget the joke. So I only can use this way to present our study today. Okay, let's go back to the presentation. In recent years, the ADAS and the automation driving system are applied in the new cars. For example, in Japan, over 65% new car had the AEB, and about 40% the new car had the ACC function in 2016. However, National Consumer Affairs Center of the Japan did a questionnaire in the last years. The 2,000 ADAS users were asked who has faced the unexpected situation during using the ADAS. In the result, there are 24% users ahead. In the detail of the unexpected situation, almost all of those situations about the acceleration. So, for this result, we have two questions. The first one, do users understand the operating conditions of the system correctly? And do users think the ADAS is usable even outside of the operating conditions? Overall, we thought maybe those users overtrusted the ADAS in some situations. The situation is that the ADAS cannot respond to the driving task. For example, using the ACC in a very busy city street. So here, we have two questions. What is the overtrust? And how does the overtrust happen? For those two questions, we did a lot of investigations. Finally, we defined the overtrust in ADAS in two dimensions. The first one is the driver is trusting the ADAS. It's a subjective. And the second one is the ADAS cannot respond to the driving task. This one is the objective. For the objective one, we can use some abnormal detection system to detect some abnormal driving behavior generated from the ADAS. But for the subjective one, it's difficult to observe the trust states of the drivers. So how to get some information that can represent the driver's trust in the ADAS? It's a very important task for us. There are many studies on the trusted relationship between the human and the machines, especially for those two studies. The first one, he investigated the change of the driver's trust when the driver was using the ACC in a decelerating scene. He evaluated the driver's trust by using the driving operation, which means it's not the subject evaluation for the driver's trust. And the second one, they also evaluate the driver's trust in automated driving system. However, they just did a questionnaire to evaluate the trust after driving experiment. However, for those two studies, there are two problems. They did not evaluate the trust in real time, and they did not evaluate the trust continuously. Therefore, in our experiment, we focus on observing the driver's trust continuously in real time. Meanwhile, we assume the right foot movement can represent the trust states of the driver when he using the ACC. So, observe the right foot movement as affected element by driver's trust is another point. In this study, we investigate the effect of the driver's trust in ADAS on the driving operation and the driving behaviors. So, there are two hypotheses were proposed in this experiment. The first one is, if the driver highly trusts in the ACC, then the right foot will be placed farther from the pedals. The second one is, if the driver highly trusts in the ACC, then the reaction time to intervenes in unsafe events become more longer. We use a driving simulator to do the experiments. There are 13 participants who join this experiment, 11 males and 2 females. The process of this experiment includes 6 steps, and the beginning is questionnaire 1. Then we introduced the experiment conditions to the participants, and the participants did the exercise of the driving simulator. For example, how to use it to control the vehicle, how to evaluate the trust states by using the driving simulator. After the exercise, participants drove the vehicle 3 trials, each trials about 20 minutes. An interview and the questionnaire too were in the end of this experiment. In the driving simulator, we created a highway with 3 lanes. On the second lane and third lane, we set many cars. We required participants to drive the car on the first lane only. There are 2 instructions for participants. The first one, driving with ACC as much as possible, but override when necessary. The second one is driving in the first lane with a max speed 100 km per hour, but overtaking is prohibited. Scenarios of each trial are shown here. We assume that the trial 1 to make the participants trust in the ACC because the surrounding car drive very carefully, and ACC could easily to do the driving task. In trial 2, the surrounding cars drove more intensely, but ACC can still keep the driving task very well. It can make the participants to trust the ACC furthermore. However, in the end of the trial 3, following a large trailer for a long time, the trailer will change the lane. Then there is a stop vehicle in front of the eagle car. In this case, ACC is not applicable. Actually, this is a very important point that we want to see the reaction time and the trust states of each participant. The function of the ACC, a distance sensor in the front of the vehicle. This sensor can detect the moving objects in 100 meters. The ACC have 2 modes. The first one is the follow mode. By using this mode, the ACC can control the vehicle to keep a safe distance to the leading car. Meanwhile, the constant speed mode can control the vehicle in a constant speed. In this experiment, we set the target speed was 100 km per hour. We also set an ACC button on the steering wheel. If you push the ACC button, the ACC function will be turned on. If pushed again, the ACC function will turn off. Meanwhile, pressing the brake pedals can also turn off the ACC function. If you want to override the ACC function, you can press the accelerator pedals. In this time, the vehicle controlled by your input. If you release the accelerator pedals, the ACC will restore to control the vehicle automatically. In this experiment, we observe those information. The driving operations include accelerator rate, brake pressures, and the steering angle. The vehicle states include the velocity of the vehicle, acceleration, and the inter-vehicle distance. And the motion of the right foot and the leg were also observed by a deep learning model called OpenPose. The observed motion information is the position of each joint point in the image coordinate. Here, only those 5 joints information were used in the analysis in the after. Meanwhile, the trust states of the driver were evaluated by the driver himself in real time. Note that the trust data is a continuous data, and it's a time series data. Maybe you have a question, how do we got that? We ask a participant to evaluate their trust states by using pedals on the back of the steering wheel. No touch means fully trust in ACC, and hold any one of the pedals means a little trust in the ACC, and hold both of the pedals means do not trust in the ACC. For example, if you don't trust the ACC, you have to hold both of the pedals until your trust will change. Based on above setting, finally we got the data from 10 participants, because some troubles happened in the experiment of other 3 participants. This graph shows that the ratio of the trust for those 10 participants Those participants were grouped in two groups, because the participants number 4 and 6 were not fully interested in the ACC in the almost time, but for other participants, they had a high ratio of the fully interested in ACC. In order to validate the hypothesis 1, we used the open pose to observe the motion information from the right leg and foot of participants. Each frame of the motion information has 10 dimensions. In order to visualize the motions, we used the PCA method to extract the two-dimensional features from the 10-dimensional motion data. We can see here, the PC result of the participant 12 can clearly show the distance from the pedals. For example, this part shows the right foot on the pedals, and this part shows the right foot in the side or front of the pedals, and this part shows the right foot outside of the pedals. Therefore, we apply the transformation of PCA for participant 12 to data of all the participants. Those figures show the PCA result of the group 1. The colors of each plot mean the log probability of the location where the right foot put on. Especially, this graph shows that if the driver highly trusts in the ACC, then the right foot will be placed farther from the pedals in some cases. Based on this result, the hypothesis 1 is not accepted completely, but part of it is correct, which means the possibility of taking a foot off from the pedals increases more as trust on ACC increases more when using ACC in group 1. However, for the group 2, it was totally opposite from the result of the group 1. The reason we thought is that the group 2 did not fully trust in the ACC in the most of the time, so they can put the right foot on anyway when they don't trust in the ACC. Meanwhile, if they fully trust in the ACC, they always put the right foot on the pedal, may they want to take over the control anytime. In the final, the hypothesis 1 was rejected in group 2. Next, we want to validate the hypothesis 2. That is, if the driver highly trusts in the ACC, then the reaction time for an unsafety event becomes more longer. So, an unsafety event is in the end of the trial 3, which cannot be responded by the ACC. In this unsafety event, there is a big trailer in front of the eagle car. The start point of this event is from the trailer speed down. After that, the trailer changed from the first lane to the second lane urgently, because there is a stopped vehicle on the first lane. For the eagle car, the ACC cannot respond to the stopped vehicle. In this situation, the driver should take over the control immediately. In this experiment, we measure 3 kinds of information for this unsafety event. They are integral trust, brake action time, and TTC, time to collision. For example, in this graph, the green color shows the integral trust. It is a summation of all the trust states from the event start to the end. We divided that fully trust in ACC as 2 points, a little trust in ACC as 1 point, and do not trust in ACC as 0 point. The blue line shows the TTC, and the pink line shows the brake pressure. Brake reaction time TB is defined as the time from the trailer changing the line to the brake pedal is pressed. The 0 point of the brake reaction time is when the trailer is changing the lane, which means here, if the brake reaction time is a negative value, it means the driver braked the car before the trailer changing the line. If the brake reaction time is a positive value, which means the driver pushed the brake after the trailer's line change. In the final result, there was 5 participants had collisions, but other 5 participants hadn't. Let's see an example of the collision group. The participant number 3. We can see that he pushed the brake at very late time, vacillatingly. On the other hand, participant 7 pushed the brake very quickly when the trailer was sped down. Let's see again. So for all the participants in the unsafe event, the integrity thrust and the brake reaction time are shown in the two figures. The left one is the integrity thrust. The integrity thrust of the collision group was more higher than it of the non-collision group. Meanwhile, the brake reaction time of the non-collision group is lower than, which means faster than, the collision group. We also compared the relationship between the collision and the integrity thrust in the trial 3 and all the trials. Those figures show that even there is no statistically significant difference between the collision group and the non-collision group in the trial 3 and in all trials, the integrity thrust of the collision group was higher than the non-collision group in all the cases. We also found the relationship between the integrity thrust and the brake reaction time, which is shown in this graph. We can see that there is a strong correlation, which is a 0.75 between the integrity thrust and the brake reaction time, which means that the high thrust in ACC will delay the operation intervention of the driver in dangerous situations. In this study, we did an experiment to investigate the effect of the driver's thrust in ADAS on driving behaviors by using a driving simulator. The result tells us if the driver highly trusts in the ACC, then the right foot will farther from the pedals, and the reaction time to the interventions in unsafety events become more longer. The strategy for placing right foot are different when the driver using ACC. It depends on each driver. In the future, we will increase the participants to retry this experiment. And we also want to analyze the data with the different degrees of trust interval for each participant, because for each participant has a different prior of the trust. In the end, we have other interesting things want to show you. Actually, we checked the right foot position for all the participants manually. We found that the density of participants' right foot position were totally different. So here, we have two open questions. The first one is, where should the feet put down when the driver is using the ACC? The second one is, should the pedal layout be changed for the ADAS and the driving automation system? Thanks for your attention.